Hey guys, welcome. I already did a video for these, but why am I making another video? I'm making another video because this is if you use the old textbook. Okay, so if you use the textbook from class or you got a handout from me, it's different because of the different versions of the test. So let's do it. If you get the question, the Gallup poll interview is 1,600 people. Of these, 18% say they jog regularly. So what does that mean? If I read this, I'm going to jot n is equal to 1,600. P hat is equal to 0.18. The news report adds, the poll said the margin of error, so the margin of error equals plus or minus 3 percentage points, okay? At a confidence level of 95. CI 0.95. Okay. Now let's attack the problem. It says, can you safely conclude what? So we're really not calculating anything. We're just saying, what are they pulling from this information? Well, if Gallup took many, many samples, 95% of those samples would find 18. Now, when you do a confidence interval, notice you're going to get a margin of, if you get a margin of error of 0.3, what you're saying is it falls between 0.18 plus 0.03 and 0.18 minus 0.03. And so essentially, you're saying that the truth, you're 95% confident the truth falls somewhere in between there. So you're not saying E at all. That is not what you're saying. Not even close when we do this. So what's wrong with this one? We can be 95% confident that the sample proportion is captured. We don't capture a sample proportion. No, we're 95% confident that the truth falls in that interval. Okay, so this is not what we are saying either. So what are we saying when we provide a confidence interval? What we're saying is, if we do a bunch of them, and this is the truth, so let's say this is the true proportion right here. We're saying if we did a bunch of them, which is why we did it in class, so let's say that's where our point estimate was, plus or minus 0.3, and here's our point estimate, plus or minus, and your neighbor did another one, and somebody in period 8 did another one, and somebody in period 1 did another one, and we just did a bunch of these confidence intervals, that if we did a whole bunch of confidence intervals, 95 of those confidence intervals out of 100 would capture it, which means every once in a while, one of them wouldn't capture it, right? So this would be your point estimate. Notice we know that the point estimate is changing. That's why E is so far off from what we're trying to say here. So what about C? 90% of the population. No, we're not talking about the 95% of the population. No, here we're talking about all the population. The percent of the population who jog is certain to be there. No, we're not certain. We're 95% confident it falls somewhere in there. So that leaves only A. And so this is the script that we believe is true. Question number 2. The weight in pounds of the 3 adult males are this, this, and this. The standard error should be what? Okay, so as promised, take a snapshot of this. This is our formula sheet. This and this, right? So using this, the standard error of the mean. So the standard error right here of the mean, I need this formula. So I'm going to copy that formula. Right? Standard error of x bar equals s sub x over the square root of n. So if they would have told me the s sub x, I just take the square root of n all over the square. We only have 3 numbers. So what's the standard deviation? You can calculate this by hand, but I suggest not. I suggest learning how to do it in this calculator. Okay? So I'm going to go, what are these values? Adult male weight. So I'm going to just call it MWT. male weight. And I have 3 male weights to enter, 160, 215, 195. Okay. So when I go to menu, stats, one stat calculator, one variable stat, yes, that's my list. My male weight, the average is 190. X bar is 190. What is my S sub X? My S sub X is 27.84. Well, that's actually here in my answer choices. So that's interesting. So 27.84. So now to finish this out, I just divide by the square root of n. So that number, 27.8388 divided by the square root of 3. All right, 1601, 1601. Okay. Question 8.3. In preparing to construct a one-sample t-interval for the population, so we're not sure about we're not sure it's normal. Okay. In which of the following circumstance would it not be safe? Okay, so we go back here, and we're definitely doing a mean, and if the population's approximately normal, we're good. Now they're saying it's not. So we need n to be greater than 30, or it has to be at least the sample's not strong skewed or outliers. So let's keep reading. We see that a stem plot of the table is, as long as, it's like not strong skewed. If it's bell-shaped, it's looking not very skewed. So that we like. A histogram showing only a slight skew. Yeah, slight skewed is not strongly skewed. A box plot of the data has a large outlier. We said no strong skew or large outlier. So C is our answer. All right, so how do we write or show work? I would write out the condition because you're trying to memorize it. Condition requires sample to have no strong skews or big outliers. All right, no strong skews or big outliers. All right. What is this last one? The standard deviation is large. That's okay. So we have large standard deviations all the time. A normal probability plot is fairly linear. Well, that's a plot built by a statistician to tell if it's normal. So this is telling you the data is pretty normal. Okay, so we like that too. So C is the one we don't like. All right, let's go to 8.4. So 8.4 said a bunch of TV viewers were expressing some doubt about the validity of a commercial. In an attempt to answer, they wish to estimate the proportion of consumers that believe what's shown on the commercial. Let P represent the true proportion of customers who actually believe what's on the commercial. What is the smallest number that Timex can survey to guarantee a margin of error of 0.05? All right, so we have to solve for N. These were like the bonus questions these are like the bonus questions. So T, 8.4. We're asking a yes or no question, do you believe? So margin of error formula for a yes or no is this one right there. So our margin of error is equal to our Z star, square root of P hat times 1 minus P hat, all over N, take the square root of everything. So here it says our margin of error is 0.05, our Z star for the 99. Okay, so the Z star for the 99, let's just Z star is our bottom line, 99. So I want this number, 2576. 2576. What's my P hat? They didn't tell me. So we assume worst case, nobody cares. Half people said, yep, I believe it. Half the people said, nope, don't believe it. And how many people did I talk to? That's the whole point. We want you to solve for that. Okay, so we're going to do some calculus, or excuse me, regular old algebra. If we divide both sides by 2.576, we get the square root of 0.25 over n on the right, and we get this fraction on the left. So, should make sense to square both sides. And now we get n on the bottom and this stuff right here on top. And we'd love to have n over here by itself. So if we square this, we now get this side to just say 0.25 over n. So I'm going to swap n up to the top, leave this 0.25 on the top here on the right, and all this stuff I'm going to put down here. All that stuff goes down on the bottom. Okay, so let's type this in our calculator. Back to calculate. So 0.25 divided by parentheses 0.05, our margin of error, divided by 2.576, our z star, parentheses, and square that. To give us our answer, we get 66357 or 58, whatever. Okay, so I have to talk to at least this many people, which means I can't humanly possibly talk to a decimal person, so I'm going to have to talk to 664. They said as least as many, so that's not enough. That's not enough. That's still not enough. That's enough. And that's enough. But it said the smallest number. So this number, 700, is smaller than 750. All right. You want to compute a 90% confidence interval for mean with an unknown population standard deviation. Your sample size is 30. What's the value of t? All right, so degree of freedom is n minus 1. So degree of freedom is 29, and it's 90. So I go 29, 90, zoom, 29, 90, zoom, 1.699. 1.699. Check out the next video.